forward. All right, now we are good to go. All right, so today we are writing algebraic expressions with up to 3 variables, as well as evaluating those expressions with multiple variables. So let's go ahead and hide these, and we will get started. Okay, all right. So a little reminder for you guys on that second slide that you have in your notes, we're going to take notes on. So we've gone over how to do substitution problems. These are problems where you're given a problem or a formula and you need to substitute in work. Eyes up here, show me star. Thank you. I have a couple people distracted by other things in their laps. They need to refocus, please. All right, so 3 lines of work. This is your second slide. Everybody should be writing. This is bright red right now. Let's go. 3 lines of work. So problem, substitute, solve. All right, that's going to be kind of relevant for today's problems. Now you guys already have this memorized, so I'm going to go ahead and go forward and you can continue to fill in those if you're still writing. First, write the problem, substitute values for variables, and solve. So let's do a problem with a couple of variables. Can somebody read this out loud for us? The first problem we've got there. Rajveer, go ahead.
Given the box X small boxes and Y big boxes and great food, how many great foods big box? What's the answer in terms of X and Y?
All right, so now we're going to draw our bar models. They're going to be a little different. You haven't really drawn, unless I corrected your homework with you, you haven't drawn a bar model like this yet. So we're going to draw 2 bar models, one for the small box and one for the big box. Now, for the small box, we know how many grapefruits are in each box, don't we? It's 4 grapefruits in each box, right? But what we don't know is how many boxes we have, right? How many boxes do we have? It tells us in the word problem. Mira? We have X boxes, good. So this is how we're going to illustrate that on our bar. Since we don't know how many units of 4 we have, we don't split it up into units. We put a little broken line like I have up here. So the units there are 4 grapefruits in each unit, but in each box, excuse me, but we don't know how many boxes we have. Now, when we illustrate the big box, again, we know how many are in each box, but again, we don't know how many, whoops, I drew those incorrectly. We don't know how many boxes we have. How many grapefruits are in each big box? Say it out loud, class. 9. Good. So let's go ahead and fill in 9 for our units. But up here at the top, we're gonna draw Y as our whole. We have Y number of boxes. We want to know how many grapefruits he bought in total. So our question mark goes over here on the side. All right. So we want to write an algebraic expression for the number of small boxes and big boxes total. Can anybody help me out with that? Got 2 variables here, but we've got the number of grapefruits in each type of box as our coefficient. McKinley, can you help me with that? Okay. Yep. It would be 4x plus 9y. And what's my unit? Grapefruits, exactly. Good. Good job, McKinley. So 4x plus 9y grapefruits. Why the 4x? Can somebody explain that to me? Cameron.
Because there's 4 grapefruits in the small box, and we don't know how many boxes there are.
Right, there are how many boxes? There are X number of boxes and 4 in each, so it's 4 times X. Good. And why 9y, Cameron?
Because the big box contains 9 grapefruits, and we don't know how many boxes there are. I don't think it's Y.
It's Y. Great explanation. Thank you. Okay, good job. All right. So, underneath your slide there, it says number of grapefruits in small boxes. Go ahead and fill that in. It's 4. Number of grapefruits in big boxes. Fill that in. It was 9. And then write your algebraic expression where it says Jimmy bought blank grapefruits. That's 4x plus 9y. Don't forget your parentheses. Michael, you had a great question earlier about like, can I do a box instead of parentheses? And I said, no, you can't. And the reason for that is like, we use a box to show our answer, like, but that's not really necessarily a math convention. And by that, I mean, like, think of the way we write things in math as math grammar, right? But parentheses is a math convention. That is a way that we have agreed upon in math. Somebody, way back in time decided that's how we were going to show that. So parentheses is like the proper way to envelop our algebraic expression before a label. And so that's why you can't really flip flop them because there is a right way to do it. Okay. All right. So let's go to the next slide. And let's see, same problem. A small box contains 4 grapefruits and a big box contains 9 grapefruits. Okay, so we're just going to walk through this. Eyes up here, please. Thank you. Knees all the way under desks. Awesome. And we're just going to walk through this problem with a couple numbers first. I think you guys are doing great with this, but we just do this to kind of get our minds used to like, okay, the number of boxes that he had was not 2, it wasn't 4, it wasn't 3, it was X. So how many grapefruits are there in 2 small boxes? And tell me the expression and the answer. Tommy, how many grapefruits are there in 2 small boxes? That is perfect. That's exactly what I wanted you to say. Yeah, there are 4 times 2, which is 8, right? Let's write that down. 4 times 2, which would equal 8. How many grapefruits are there in 3 small boxes? Macy. That would be 12. Great job. How many boxes are there in 4? Are you guys getting the idea?
Yeah.
How many boxes are there in 4 small boxes, Ashlyn? Well, tell me the equation first. Yes, 4 times 4. Oh, it won't do what I want it to do. Which equals 16. Great job. And then the final question is, how many grapefruits are there in X boxes? Shafi?
4x.
4x. Good. Easy peasy lemon squeezy, right? Good job, guys. Okay. I'm looking around and I just want to make sure you guys are taking notes. You can take them on the slide or you can take them in the blanks underneath the slide. But make sure you're caught up before we move on. All right, the next thing that we're going to do now is we're going to substitute, and we're actually going to evaluate this expression where we have some numbers to plug in for X and Y. Okay, so same problem again. This time, X is going to equal 5 and Y is going to equal 7. And we're trying to find out how many grapefruits Jimmy bought altogether, okay? So let's start with the small boxes. First of all, what was our algebraic expression for the number of grapefruits in the small box? Maybe go back 2 slides if you can't remember. Rajveer? It was 4x, okay? So on that slide on the next page, where it says number of grapefruits in small boxes, it was 4x. Remember, we always start off with the problem or the formula. What am I substituting in for the X according to the problem? Lucy Cole? Good. So my next line of work now, formula substitute solve, is 4 times 5. So we want to find out how many grapefruits Jimmy has in the small box. How many does Jimmy have in the small box? Stella, are you with me? How many does he have in those small boxes? He's got 20 grapefruits. Good. Let's move on to the big boxes. Michael, eyes on me, please. Thank you. All right, a small box contains 4 grapefruits and a large big box contains 9. All right, X equals 5, Y equals 7. Whoopsies. What was our expression for the number of grapefruits in the big boxes? Check back 1 or 2 slides. Mira?
Y.
It wasn't just,
Or it was 9.
it was 9Y because we have 9 grapefruits in each box. Next line, what does my next line of work look like? We're substituting in 7 for Y. Kylie? Good job. How many grapefruits does he have in the big boxes? McKinley? 63 grapefruits. Good. Oh, my pen is not working the way I want it to work. Okay. Good. So we've got how many grapefruits he has in the small box, and he has eyes up here, please. Put that away. Thank you. We're taking notes right now. Your hand should be busy doing that. How many grapefruits does he have altogether? Just tell me, you guys. 83, right? Okay. So go ahead and fill that out. He had 20 in the small box. He had 63 in the big box. This is your next slide. So that means that Jimmy bought 83 grapefruits. Morgan, what are grapefruits? Oh, they're like the big, they look like giant yellow oranges. And when you cut them open, they're pink on the inside. And they're kind of sour. They're not my favorite. All right, let's move on, guys. Different kind of problem this time. We are going to do a problem with not 1, not 2, but 3 variables. Okay. Alrighty. So we've got a chart in front of us, and it's got fares for children, adults, and senior citizens. How much is it for a child to ride the bus? Look at your chart. Evelyn, can you tell me? Whoopsies. How much does it cost for a child to ride the bus? It costs X what? Good. How much is it for an adult to ride the bus? Cecilia, can you tell me? No, that's for a child. How about an adult? Good. Why? How about for a senior citizen? Mendel, can you tell me? Z cents. Great job. So we've got these different fares for all of our aged people, all of our ages for people. All right. How can I write an algebraic expression for the bus fare for 2 adults? What would my answer be there? Piper. Well, I'm looking at the adult. I need to look at the adult line. 2Y cents. Oh, so we can put it right here. 2Y cents. Good. Okay. Got that? All right. How about the bus fare for 1 adult and 3 children? Let's start with the children. What's the bus fare for 3 children? Lucy Cole.
X.
Good. So it's 3 times X, but what do we need to put first? You said X3. Do we put the variable or the coefficient first? Yep. So then revise your answer and it would be, you got it. Nice job. 3X cents. Now we want the bus fare for 3 children and 1 adult. Can anybody help me out with that? Dorothy, do you have it?
3x plus y.
Yes, great job. Thank you for not saying 1y, because we don't write the 1 when the 1 is the coefficient, right, guys? Is there another way I could write that? I could, right, because addition isn't in any order. But here's a thing, you guys. Addition is in any order. So it is acceptable to write y plus 3x in 6th grade. But I will give you guys a heads up that in later grades, you're going to put the variables in alphabetical order. So it's best to get in the, actually, yeah, it's best to get in that habit now. So anyways, that'll be for the future. All right. Oh gosh, now we need to write an algebraic expression for 2 adults, 3 children, 1 senior citizen. Who thinks they can do that? Give it a try, guys. Go ahead and write it on your slide and then raise your hand. Good job, guys. Keep your hands up there as you're finishing up. Nice. I love it. Lucy M., can you give me the answer? Oh, we missed one thing. You got it partially white, right? We've got the children. Okay, hold on. Let me write what you said. You said 3x and 2y. We're right so far, but you said and one senior citizen. What do I need to write in for the senior citizen? No, we're doing the total for all of these. Plus z. Great job. 3x plus 2y plus z cents. Way to go. How are we doing? Give me a thermometer. With 3 variables, you guys all have your thumbs up. That's great. Way to go, class. Open up your textbook to page 22, please. We're going to do a few Toyos. You guys are going to do number 4A and 4B. So maybe you didn't need to do that, but I'm just going to go ahead and replicate them up here really quick for you. So you had X number of 27-cent stamps. You had Y number of 42-cent stamps. And you had Z number of 59-cent stamps. Okay, so how much are my X number of how much are my 27-cent stamps worth? Kylie? Well, no, I have X number of stamps. So how much are they worth in cents? 27 X cents, right? Because if we're counting up how much they're worth, they would be 27 times X. Like, let's say we have 10 of them, then you would have 270 cents. Does that make sense? How about the Y, the 42-cent stamps? How much are those worth altogether? Lucy M?
42Y.
Yes, great. And how about the Z? I'm sorry, how about the 59-cent stamps? How much are those worth? Declan?
59 cents.
59 Z cents. Good. Okay, and then for my algebraic expression to show how much everything is worth altogether, Ashlyn Grand Prix. $27X plus 42Y plus 59Z cents. Okay. So now let's go to the next problem. Do we all have our expression right? We ready to go on? Let's do some substituting. So now we want to know how much Mr. Taylor has to pay for the stamps. And I get my expression again was 27X plus 42Y plus 59Z. So that's my first line of work. My second line of work is substituting. What do I substitute in for X, folks? Rajveer? Oh, I didn't go to the right slide here. I need to go one more slide. There we go. Whoops. Okay. 27X plus 42Y plus 59Z. Okay, it says that X equals 4. So I'm going to do 27 times 4. I'm going to go ahead and put that in parentheses just so that I know to do that first. Or I'm sorry, not how much. What did they say to substitute for Y, friends? 5. So plus 42 times 5. And then for Z, what are we substituting? 3. Okay. All right, let's do this in our heads. You guys ready? Okay. 27 times 4. I would do 25 times 4, which is 100, and 2 times 4, which is 8, and I would add those together and I would get 108. Good. And let's do 42 times 5. 40 times 5 is what? 200. I thought I heard 400 for a second there. And 2 times 5 is, so we have 200 in. Okay. And 59 times 3. Let's do 60 times 3. What's 60 times 3, folks? 180. And whoopsies. And we need to subtract 3 because we only wanted 59 times 3. So 180 minus 3 is, okay, 177. Did we get all our mental math right, you guys? I think we did. All right, let's add them all up. Stella, do you have the answer? I did. Whoopsie daisies. Thank you for correcting that. I don't want +3. That's not right. Okay. What do we have for an answer to Lucy Cole? 495 cents. Great job. Now, do we usually count things in cents, you guys, when we're talking about money?
No.
What should we convert that to, maybe just to make it more normal? Like, nobody says 495 cents. That's ridiculous. What should that be? Morgan? Equals $4.95. Good. Do you want to go to the counter and pay 495 cents, or do you want to go pay $4.95? All right. Okay, guess what? Guess what the homework is for tonight?
Exercise 6.
So what I want you to do is, with today's notes, I want you to go home and check your work from yesterday. So you're going back over the problems and you're making sure that you have those right. All right. So we've got 4 minutes. We're not done, folks. Go ahead and get started on that task right now, please.